So we're on chapter 25. We just skipped 20, 21, 22, 23, and 24. I didn't hear any complaining, so we're good. Chapter 25 is about transition metals and coordination compounds. And the quote is from Alfred Werner, who was one of the pioneers in working with coordination compounds. And the quote is, "Chemistry must become the astronomy of the molecular world." So here we have a picture of a ruby and an emerald. Very brilliantly colored stones. Now, I think everyone's familiar with what a diamond is, right? It's pure carbon, covalent network solid. What are these other gemstones? You ever thought about that? Why do they have such pretty colors? They're ionic compounds, but not like sodium chloride or anything. Their formulas are much more complicated. That's why we didn't tell you about them in Chem 1A. Because in Chem 1A, ionic compounds have two ions, one cation and one anion. And now we're learning that that's a lie because some of them have multiple cations and anions. So the colors of both of these stones, which are kind of like opposite colors, come from the same ion, and that's from the chromium-3 ion. So these are compounds of aluminum, but because there's about 1% of the aluminum ions have been replaced with chromium ions, that gives a different color to the substance. So the atoms in the host crystal, so the aluminum ions, create a field around those chromium ions, sort of an impurity. It's called a crystal field. And that splits normally degenerate d orbitals. So normally there's 5 d orbitals and they're all the same energy, right? That crystal field causes the d orbitals to split. So some are a little higher in energy, some are a little lower in energy. There's at least 2 levels, there could be more. Because of that splitting of the d orbitals, now when electrons move between those 2 different levels or 3 different levels, we can get absorbance and reflectance of light. And so it interacts differently with white light than it did before. And so that's why this one's green and that one's red. It's the electron transitions. Any questions?